Hey everyone, today we're going to have a look at transforming data to linearity. So sometimes when we make our regression line and we find that we have a good fit of the data, meaning we have a high R value, the data may still be nonlinear. So we need to be able to remove the nonlinearity from the data, and so we need to transform either the x values or the y values or both. So transforming them, we can use a few different transformations, and we'll have a look at those later on. And when we transform the data, it enables us to make more accurate predictions from the regression equation. So there's essentially 6 transformations. We've got logarithmic, quadratic, and reciprocal. Now for each of those we can transform both the x values and then both the y values. So we get 6 in total. And it is important to choose which transformation is going to be the most appropriate. And so we make what's called a circle of transformations, which will help us choose which transformation to use. So the circle of transformations, we have types of scatter plots can be transformed by, as I mentioned before, the squared, log, or reciprocal transformations. And we can fit them all together to make a nice circle I'll show in a moment. And the purpose of the transformations is to guide us in which transformation to use to linearize the data. It's important to note that in each case there are more than one type of transformation that might work, and these transformations only apply to scatter plots with consistently increasing or decreasing trend. So here's our nice little circle, and essentially what we do is once we make our scatter plot, we determine which one our scatter plot looks like. So we've got 4 possibilities. So if we have a scatter plot which looks kind of circled up in this corner up here, all right, it's decreasing as we go down, and we've got a bit of a curve to it. All right, so in that case we would look at using the y squared and the x squared. All right, it eliminates some of the transformations that we need to use. So there's no point using a log function because it's more appropriate to use one of these two. Moving over to this one here, if we have the data, our scatter plot, and it looks something curving upwards, okay, we can use these 3 transformations here. Okay, so for this example we wouldn't need to use the x squared, so it just eliminates how much work we have to do. All right, and with the other 2 down below. So it'll make more sense in a example, which we'll do right now. So worked example 14. We've got a set of data, x and y, and like most cases we're going to put these on our calculator and then make a scatter plot as our first step. So if we get our calculator up and going, alright, so I've got my set of data originally this was list 1 and list 2. I've just changed it so we've got x and y first and then put the data in. Now remember, if you put the data in first and then change the thing, it's going to delete all the values. So make sure you change the name first and then put the values in. So I've got list 1 and list 2, and just like what we've been doing, we're just going to make our scatter plot. So using our set graph function, just make sure that we've got our right values in. Now I've changed my x values to x. So if you scroll down, it'll actually say main/x. So that's only if you change the data, the name of the data. And for list 2, we've changed it to y, so it's main/y. And we want a scatter plot. So that's all we need to do there. So set, and now we just need to sketch it. So tapping on our graphing function, and we get something that looks like this. Okay, so as you can see, it's clearly not a straight line. We've got a bit of curve to it. All right, and if we do that, it means that we need to apply a transformation. Now it's asking to apply a quadratic transformation. So if we go back to our data, in list 3, I'm now going to change that to quadratic. So let's say x squared. Let's see if that works. No. I'm going to call it z. So this is our x squared list. Now remember, I could go in this cell saying 1 squared, which would be 1. So I could type it in manually, and my x is 2, so squaring that would be 4. Right, and so on and so forth. Now, there's a quicker way of doing it, and that's by using the calc function down the bottom corner. Now, I've done this a few times. We just need to say we want our x list, so x, and we're going to square it. And then click enter, and it should do it for us. Yep, there we go. All right, so that's our squared values for x, or a quadratic transformation. And if we actually go back to our set graph, and we're going to change our x list now to those ones that we just made. So it's going to be z. Click set. And now let's see what happens when we graph that. Okay. All right, as you can see, it's a little bit better, not a huge amount. But we can now compare what our transformation has done. So if we go up to calc, regression, we want linear regression. We've actually got list x was our z, our x squared, and we've still got y. Okay. We find that we get an R value of 0.95. So that's pretty strong. We didn't do it before, but let's go back and just compare what our original data was for the regression. So if we go calc, regression, and this is for just our original data, which was x and y. Click OK. All right, and as you can see, this was our first, what we should have done first actually, 0.86. Okay, so 0.86 was pretty strong, but after we made a quadratic transformation, we find that it's actually even stronger as 0.95. Okay, it didn't look like much on the scatter plot, but we have actually increased our how strong the relationship is between the two. Okay, so that's all we need. That's all that question 14 is talking about, just using the quadratic transformation. Let's move on to example 15. So we've got another set of data. We've now got time after operation for, I'm guessing a surgery or something. So we've got heartbeats, so we've got X and Y, and like before, we're just going to put our data in our calculator in list 1 and list 2. So I'll just pause the video and put that in. Okay, so once you've put that data in, okay, again I've got X and Y as my two lists. Now part A says transform the data by applying a log transformation to the Y variable. So over here I'm going to have, let's use Z again. I'm going to clear all those ones because that's from the previous example. Now down here, all right, it's going to be easier to make the transformation by using our calc function. And we're going to now bring up our keyboard, and we want this log function. So just tap the log. We've seen this before, and this time we're going to have our y values. So it'll be log 10 comma y, and click enter. And as you can see, we've got all our values already done for us. Part B says calculate the equation of the least squares regression for the transformed data. So if we go up to calc, regression, linear regression, now our x list hasn't changed, so that's main/x, but our y list is now the log functions, which we labelled as z. Click OK, and we find that we have an R value of minus 0.92 or 93. So pretty strong correlation there after we made the transformation. We've got a negative, which means we've got a negative relationship. Doesn't matter, it's still strong. So that's a application of using the log function. Last example, example 16. So we've got temperature and number of students in a class wearing jumpers. Using CAS, we're going to apply the reciprocal transformation. So if we go back to our calculator and put those values in, again, I'll just pause it and do that on mine. Righto, so once you've put those in, is x and y, it asks to apply a reciprocal transformation. So I'm going to, again, we're going to have our z list. And we're going to go down here and we're going to transform a reciprocal function. And that just means we're going to have 1 divided either the x or the y. Sorry, just so you can see, so down down in our calc function, we're going to have 1 divide, and we're going to choose x. Okay, so this is our last type of transformation, is the reciprocal, so it's just 1 over either list x or list y. Click enter, and we get all our values there for us. And we're going to use the transformed regression equation to predict the number of students wearing a jumper when it's 12 degrees. So we need to first find what our regression equation is. And we now have our x values as the 1 over x, which is z. We still have y. Click OK. And we find that we have 2.5 for A, and B is 41.2. So once we've got those jotted down, we now go to our main function, or our main document. Oh, actually no, sorry, go back. Alright, so once it's graphed it for us, hang on, something doesn't look right. Righto, sorry. So just going back to the start, I actually had one of my data as 5, not 35 over here, so I've just fixed that up. Now we still have 1 over x for that data there. Again, just go calc, regression, linear reg. We've got, our 1 over x, which was z, and our y there. So we find that we get minus 0.435 and 94.58 as A and B. So you can jot those down and use that equation in our main document, but if we just click OK, we should get our scatter plot, our transform scatter plot, and our regression line. So that looks much better. Now we actually want to find the temperature, or sorry, the number of students wearing jumpers when the temperature is 12. If we just go up to analysis, and I think if we go trace, yep. So we should get this little pink dot. We want the value when our x, or 1 over x, is 12. So if we type in, I'll just tap any number, our x value is going to be 1 over 12. Click OK, because remember our x values are 1 over x, so it means we have to have 1 over 12. Our temperature is 12, so 1 over 12. And we find that we have a y value of 7.447. Okay, so that's basically how we do that one. So we can say that 7 students are predicted to wear jumpers when the temperature is 12 degrees. Okay, so that's all about transforming data. So I'm going to leave it there. Have a go at the questions. Thanks for watching.